Hello students, Assalamu alaikum. I hope all of you doing well. Advanced Mathematical Economic course. Today we are going to explore the numerical. In the previous lecture, we explore and derivate the general solution of the particular function and the uh, complementary function. And today's lecture, we will solve the numerical example for further clarification and comprehensive understanding of the solution of the difference equations. So, quick outlines, summary of the previous lecture and numerical example. So, summary of the previous lecture include we have derived the following general and the definite solution of the first order difference equation. Standard form of the first order difference equation include the yt plus 1 plus ayt is equal to c, and there are two types: non-homogeneous if c does not equal to 0, yt plus 1 plus ayt is equal to c, and homogeneous if c is equal to 0, that is the right hand side is equal to 0, yt plus 1 plus ayt is equal to. Further we assume the y complete solution is equal to the sum of the complementary function and the particular function. So yt is equal to yc plus yp, equation number 4. Particular solution of the equilibrium solution yp. So yp is equal to c over 1 plus a we derived previously, and complementary function yc. So yc is equal to arbitrary constant capital A into minus a c to the power t. Obtaining the general solution, if a does not is equal to 0, yt is equal to capital A, that is the arbitrary constant, into minus a to the power t plus c over 1 plus a, equation number 11. Definite solution, if a does not is equal to 0, so a is equal to y naught minus c over 1 plus a by substituting t is equal to 0 initial condition. So yt is equal to y naught minus c over 1 plus a into minus a to the power t plus c over 1 plus a is the definite solution where there is no value of arbitrary constant. So general solution, if a is equal to 0, if a is equal to minus 1, yt is equal to a plus ct. Definite solution, if a is equal to minus 1, here a is equal to y naught. If we substitute t is equal to 0, so definite solution yt is equal to y naught plus ct, equation number 16. Let's solve the example. Example number 4, page 55 of the Alpha C Chang book, 4th edition. So question, solve the following difference equation. Here is the question: yt plus 1 minus 5yt is equal to 1, and initial condition y naught available, y naught is equal to 7 by 4. So how we solve? There is a very easy method. First of all, in the first step, we take the standard form. This we take the standard form of the first order difference equation. So it is yt plus 1 plus ayt is equal to c. Compare both equations, the question and the standard form, to take the value of a and c. By comparing with the standard form, we will get a is equal to minus 5 and c is equal to 1. This is the first step. Again, I explain the first step. In first step, we take the standard form yt plus 1 plus ayt is equal to c, and compare with the question and find the value of a and c. Here we compare a is equal to minus 5 and c is equal to 1. Now we use the previously derived formulas, because our aim is to find the complete solution. Yt is equal to yc plus yp. First of all, we find the yc. As we know that yc is equal to arbitrary constant a into minus a to the power t from equation number 10. substitute the value of a. Here a is the minus 5. Substitute the value of a. When we substitute the value of a minus 5, we will get yc is equal to a into minus c minus 5 to the power t. So minus into minus plus. So yc is equal to a into 5 to the power t. For particular solution, as we know that previously derived formula, yp is equal to c over 1 plus a. Here we substitute the value of c and a. C is equal to 1 and a is equal to minus 5. So yp is equal to 1 over 1 plus minus 5. So yp is equal to minus 1 by 4. Now we obtain both values, yc and yp. By substituting the value of yc and yp in equation number 4, we will get the general solution. The general solution, yt is equal to yc plus yp. By substituting the values, here the general solution is equal to yt is equal to a into minus a to the power t plus c over 1 plus a from equation number 11 previously we derived. So yt is equal to a into 5 raised to the power t minus 1 over 4. This is the general solution of the first order linear difference equation. Now we want to find the definite solution. For definite solution, we assume the initial condition t is equal to 0. By taking the general solution, yt is equal to a into 5 to the power t minus 1 over 4. If we put the value of t 0, y naught is equal to a into 5 to the power 0 minus 1 by 4 by putting t is equal to 0. So y naught is equal to 7 by 4. Y naught is equal to 7 by 4, as we know that y naught given the initial condition given in the question. By substituting the value of y naught in above equation, we will get 7 by 4 is equal to a into 5 raised to the power 0 minus 1 by 4. Solving for a, 7 by 4 is equal to a into 1 minus 1 by 4, because 5 to the power 0 is equal to 1. So a is equal to 7 by 4 plus 1 by 4 is equal to, by taking the LCM, 7 plus 1 by 4 is equal to 8 by 4 is equal to 2. Here we find the value of a. So a is equal to 2. Definite solution. Now we substitute the value of a in the general solution. Here yt is equal to y naught minus c over 1 plus a into minus a to the power t plus c over 1 plus a. By substituting the value of a, we will get the definite solution. The definite solution is the yt is equal to 2 into 5 raised to the power t plus 1 by 4. So why we called the definite solution? Because there is no arbitrary constant available in the solution. So our next task is to the interpretation of the difference equations, that is the dynamic stability. Now we talk about the dynamic stability. Dynamic stability of the difference equations depends on the absolute value of the exponential growth component, that is b to the power t, which is definitely is equal to minus a to the power t. Now we explain step by step the dynamic stability of the difference equations. If absolute value of b greater than 1, in this case the absolute value of b is greater than 1, which means that the exponential term b to the power t grows rapidly as t increases. This leads to unbounded growth of yt over time, indicating the dynamic instability. The what happened if absolute value of b less than 1? If b in absolute term less than 1. Conversely, if absolute value of b is less than 1, the exponential term b to the power t decreases rapidly as t increases. In this scenario, yt approaches to 0 over time, indicating dynamic stability. Absolute value is equal to when? If absolute value is equal to when the absolute value of b equals 1, the exponential term b to the power t remains constant over time. In this case, the behavior of the yt depends on constant term c. So there are two scenarios: if c is equal to 0 and if c does not is equal to 0. In case of if c does not is equal to 0, yt does not converge and exhibits dynamic instability. If c is equal to 0, sequence remains constant over time, indicating dynamic stability. Thank you for watching.